Welcome back. Problem 12-26. So statement of problem is determine the maximum deflection of rectangular simply supported beam. The beam is made up of wood having modulus of elasticity E is 1.5 into 10 to the power 3 KSI. So you can see this is a simply supported beam of that is made up of wood. The cross section is shown. Height is 6 inch while width is 3 inch. And there is a point load of 600 pound at this distance from this point B, which is 4 feet, while the other distance is 8 feet. The total length of this beam is 12 feet. So due to this loading, this beam will bend like this. Clear? So we will find the maximum deflection. So let's start with the solution. So first step is that if we remove this support at point A, so you will be having a reaction force which is RA, and if you remove a roller support at this point, so you will be having a reaction force which is RB. So we will find this reaction force by using equilibrium condition that sum of all moment about point B is equal to 0 and taking the counterclockwise moment as positive. So at point B, the first moment is 600 and perpendicular distance is 4, and that is counterclockwise, so it will be positive. The other moment which is RA, which is RA and perpendicular distance is this 12 feet, and it is producing clockwise, so it will be negative. So I will write here 600 into 4 minus RA into 12 is equal to 0. So from here you will get 12 RA is equal to 2400. So RA will be equal to 200 and the unit will be pounds. Now you have this RA, you can find RB using another equilibrium condition that sum of all forces in long y direction must be equal to 0 and taken upward force is taken as positive. So you can see that you have one is RA plus RB minus 600 is equal to 0. So RA is 200 minus 600 plus RB is equal to 0. So from here you will get RB is equal to 400 pound. Now you have both these forces. So we will first section the beam over here and we will draw the free body diagram. So when you cut it and you draw the free body diagram, so here you can see you have RA which is equal to 200, and here this distance is, let this distance is x1. So when you cut it, you will be having a shear force V of x1 and you will be having a moment that is m1 of x, and at this point is 1. So we will apply equilibrium condition sum of all moment about point 1 is equal to 0 and taking the counterclockwise moment as positive. So about point 1 we have one moment which is 200 into x1 and that is clockwise, so it will be negative, and this moment which is m1 of x, this is positive. So I will write m1 of x minus 200 into x1 is equal to 0. So from here you will get m1 of x is equal to 200 into x1 and the unit will be into pound into feet. Okay, so this is the moment when you cut the beam along the coordinate x1. Now what if we cut the beam at x2 and draw the free body diagram? So I will draw the free body diagram. This is point B where you have 400 pound force is applied and this distance is x2. Okay, so when you cut it, you will be having a shear force which is V of x2 and there will be a moment that is m2 of x, and let this is your point 2. Now we will apply equilibrium condition that sum of all moment about point 2 is equal to 0 and taking the counterclockwise moment as positive. So about point 2 we have one moment which is m2x that is clockwise, so it will be negative, and the other moment is 400 into perpendicular distance is this, and this is counterclockwise, so it will be positive. Their sum must be equal to 0. So I will write m2 of x minus plus 400 into x2 is equal to 0. So it means that m2 of x is equal to 400 x2 and unit will be equal to pound into feet. Now you have both these movement equation for coordinate x1 and x2 clear. So what we will do is that we have equation of slope and elastic curve, because we need the equation of slope in order to find the maximum deflection. So this equation is ei into d square v, where v is deflection and x square is equal to m of x. So what we will do is that for x1 coordinate, we will write this equation in term of x1 coordinate. So it will be equal to ei into d square v1 over dx1 square is equal to m1 of x, and m1 of x is 200 x1. So integrate this equation, integrate it, we will get ei into dv1 over dx1 is equal to 200 x1 square over 2 plus c1. And if you divide ei on both sides, so you will get dv1 over dx1 is equal to 1 over ei into 100 x1 square plus c1. Let this is your equation number 1, that is equation for slope for coordinate x1. Again integrate it, so you will get v1 is equal to 1 over ei, and this will be equal to 100 x1 cube over 3 plus c1 x1 plus c2. That this is your equation number 2. Now we will use it for coordinate x2. So for x2 coordinate, we will having this equation ei into d square v2 over dx2 square is equal to m2 of x, and this m2 of x is 400 x2. So integrate this equation, integrate it, we will get d square d square, we will having ei into dv2 over dx2 is equal to 400 x2 square over 2 plus c3. Now if you divide ei both sides, so you will get dv2 over dx2 is equal to 1 over ei into 200 x2 square plus c2. Again integrate it, I will write it again, integrate above equation, so you will get v2 is equal to 1 over ei into 200 x2 cube over 3 plus c2 x2 plus c3, and let this is your equation number 3, and this is your equation number 4. Now you can see that c1 c2 c1 c2. Okay, so we have to change it. This is c3 that is mentioned over here. So sometime it's a lengthy problem, so I may get confused. c3 and this is c4. Now you can see that c1 c2 c3 and c4 are constant of integration, and we do not know the value. So what we will do is that we will use boundary condition in order to find this c1 c2 c3 and c4. So what are the boundary conditions? So first boundary condition is at x1 is equal to 0, v1 is equal to 0. So you have to put in equation number 2. I will show you the boundary condition. So you can see here at x1 is equal to 0, we have deflection is equal to 0 at this point. So when you put this in this equation, so x and x term and v1 will be equal to 0. So we will left only c2 over ei is equal to 0. It means that c2 is equal to 0. So you can just put it and you will find that c2 is equal to 0. Now another boundary condition is that at x is equal to x2 is equal to 0, we have v2 is equal to 0, and you have to put in equation 4. Why equation 4? Because you can see equation 4 is about v2, which is deflection at point 2 due to x2 coordinate. So I will show you here, this x2 is equal to 0, we have v2 is equal to 0. So again you can see that if you put x is equal to 0, this term will be 0, this term, and v is equal to 0, it means that c4 is also 0. So I will write c4 is equal to 0. Now the another boundary condition that we will use is at x1 is equal to 8 feet or x2 is equal to 4 feet. We have dv1 over dx1, slope at this point will be same, but that will be minus. I will show you here. You can see this is the point where x1 is equal to 8 feet and x2 is equal to 4 feet. So at this point, deflection due to x1 is equal to minus dv2 over dx2, because x1 is in this direction and x2 is in this direction. So what we will do is that we will put x1 is equal to 8 feet in equation 1 and x2 is equal to 4 feet in equation 3, and then equate. So you can see this is equation number 1. So I will write 1 over ei into 100 times 8 square, because x1 is 8. So 8 square plus c1 is equal to 1 over ei, this is equation number 3, into 200 multiplied by 4 square plus c3. Okay, so you will get, this will cancel and you will get the final equation c1 plus c3. Okay, so what I have done is that you can see there is a negative sign over here as well. So this will be negative. So c1 plus c3 will be equal to minus 9600. So this is your equation number 5. The last boundary condition is that at x1 is equal to 8 feet and x2 is equal to 4 feet. We have v1 is equal to v2. Deflection will be same. So at this point you can see that if I draw it, so at this point both deflection v1 and v2 is equal to v1 is equal to v2. So you have to put x1 is equal to 8 feet in equation 2 and x2 is equal to 4 feet in equation 4, and then equate them, because we have this condition v1 is equal to v2. So we have, if you put x is equal to, this is the equation, So 1 over EI into 100 8 cube over 3 plus C1 which is not known into x1 which is 8 plus C2, and C2 is, you can see this is 0, is equal to 1 over EI into 200, x2 is 4 feet, so 4 cube divided by 3 plus C3 into 4 plus C4 is 0. This will cancel with this, and we will, after solving this, you will get 4 times C3 minus 8 C1 is equal to 12,800. So this is your equation number 6. Now solve equation 5 and 6 simultaneously. I will not solve it, you will solve it again. Solve equation 5 and 6 simultaneously. It's a very easy. You will get C1 is equal to minus 4266.67 pounds into feet square, and C2 will be equal to minus 5,333.33 pounds into feet square. So now you have C1, C2 as well. So what we will do is that you can just put it in V1 equation. Here in this equation, equation number 2, you can just put the value of C1 and C2 in this equation. So I will write, put C1 and C2 in equation 1 to get V1. So V1 will be equal to 1 over EI into 100 x1 cube over 3 minus sorry, one here, this is C3, C2 is 0, so minus because you can see equation 5 and 6 is about C1 and C3, and equation 6 is C3 and C1. Okay, so minus 4266.67 is C1 into x1 plus C2, and C2 is equal to 0. Now what we will do is that you can see here that if I draw, due to this load, this will be the deflection. So maximum deflection will be here, V max, where you can see how we can find this x. So here we will have dv1 over dx1 is equal to 0, because tangent to this line will be 0. So thus how you can find this distance x1? So you will do it, you have to put C1 value over here, and you will take dv1 over dx1 is equal to 0 and solve for it. So you will get x1 will be equal to 6.5320 feet, where we have a maximum deflection. Okay, so I will write it over here. We have equation dv1 over dx1 is equal to 1 over EI into 100 x1 square plus C1. So C1 is minus 4266.67, clear. So when you can see that V max will be there when dv1 over dx1 is equal to 0. So you will take it 0, and that will be equal to 1 over EI into 100 x1 square minus 4266.67. So when you solve this, you will get x1 is equal to 6.5320 feet. So at this distance we have maximum deflection. So we have to put this value in this equation to get the maximum deflection. So V max is equal to V1 at x1 is equal to 6.5320, that is equal to 1 over EI into 100 into 6.5320 cube divided by 3 minus 4 to 66.67 into 6.5320. Okay, so you will get V max is equal to minus 18579.83 into 1728, and we will have E into I. Now the value of E is given, so V max is equal to minus 18579.83 into 1728, clear, divide by E is given as 1.5 into 10 raised to power 3 ksi. We can see 3 ksi, so we will also consider 10 raised to power 3, so it will be 10 raised to power 6. So 10 raised to power 6 multiply by I for this circular shaft, solid circular shaft having diameter is equal to 100 millimeter, or that is D is equal to 0.1 meter, and its radius will be equal to C divided by, okay, sorry, we have, this is a rectangular beam. I just remember that this is a rectangular beam. Okay, 6 by 3. So you have a rectangular beam, this is 3 inch and this is 6 inch. So I for that is equal to 1 over 12 P, which is 3 and 6 is cube. So we will write 1 over 12 3 into 6 cube, and when you solve this you will get V max will be equal to minus 0.396 inch, or if you want to remove this minus sign, so 0.396 inch, and deflection is downward. So this is the answer of our this question, and deflection at this point will be V max is equal to 0.396. And this was all about problem 13.26. I hope you have enjoyed this video. Again, those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. Again, if you have any question, you can ask me in comment section. Thank you for watching.